Our goal today is to write and solve equations. And we have to define a solution to an equation. Does anyone know what the solution to an equation, how we define that? Not just x.
Oh, like once you find like what your variable is, you plug it back in?
Yes.
And then figure out what it would be like in the original problem?
Yeah, so once you find the number, if you plug it back in and then the equation is true, then you know that that is a solution. Yeah. Yep, so it's a number that makes an equation true. So if I gave you an example, maybe I gave you the equation 7x plus 3 equals 24. And I said, is x 2? And is 2 a solution? And what we would have to do in order to find that is you would actually plug it in. And you'd say, okay, well, 7 times 2 is 14, plus 3 is 24. 17 is not 24, so that equation is not true. So then we know this is not a solution. Do you remember doing stuff like that before, way long ago? Okay. All right, so now we actually have to solve to find a solution. So this first one, give me like a 1 through 5. I'm pretty sure I can handle this on my own. Down to a 1, I've never seen anything that looks like this before in my life. Okay, so I'm just going to quickly go through this and we'll see how it turns out. So the first thing you want to do is you want to get all your variables to one side. So I would subtract 3a on both sides, and you would get 3a minus 4 equals 14. And then I would move that minus 4 to the other side as well. So in order to undo that, I need to add 4 to both sides. And I get 3a equals 18. And then you can divide both sides by 3. And we get that a is equal to 6. Now we have to check to see if that is a solution. So we plug it back in. That's how we check our answers. And I'm pretty sure on your assignment it does tell you to check your answers. So 6 times 6 minus 4 equals 3 times 6 plus 14. 36 minus 4 is 32 on that side. And this one's going to be 18 plus 14, which is also 32. And that's how we can check our solution, is that equation is true. 32 is equal to 32. Give me a 1 through 5. I'm pretty confident I can do that on my own. Okay. So we're feeling okay about that? All right, how about this next one? This one is like, oh no, there's parentheses. How do we feel about this one? Could we handle it on our own? Or is this something you've never, parentheses have ruined my life? Okay, so are parentheses scary? A little bit maybe? How do you get rid of parentheses? Distribute. Distribute. So if we can just take and distribute this -2 and distribute this 2, then we won't have parentheses anymore. So when we do that, we get 3x minus 2x minus 8 is equal to -2x plus 4. Are we okay with how I got that? All right, well, now that's no different than the number 1, other than there's a couple x's on the left side, but we know how to simplify because we did that in 1.2. So if you simplify, that just means combine like terms, right? So 3x minus 2x is just x, so that side's actually x minus 8. And now let's just move the x's to one side. So I would add 2x to both sides. We're trying to get x alone, so we're going to have to add 8 to both sides. X is still being multiplied by 3, so we're going to have to divide both sides by 3. Give me a 1 through 5. I think I can handle a problem like this on my own. Down to a, I hope I never see something like that again. Okay. So we're feeling okay about that one? All right. So the next step then is we're going to have to check our solution. So let's plug in 4 to our original. So 3 times 4 minus 2 times 4 plus 4 is equal to 2 times negative of 4 plus 2. Oh, you guys can't even see what I'm writing. There we go. All right, so I just plugged in 4 everywhere, back to my original. And from there, I'm just going to simplify. So if you cover up the right side and simplify the left, that's exactly what we were doing yesterday with expressions, just simplifying them. So you're going to work from the inside out. So inside these parentheses is 4 plus 4, so that's 8. So again, you're ignoring the right side for right now. Okay? With PEMDAS next, you're going to take care of the multiplication. So this becomes 12, and that's going to become 16. 12 minus 16 is negative 4. So now we have to go through and we're going to simplify the right side and hope that it's also negative 4. And if it is, that means that we found our solution and that it is correct. So we're going to cover up the left side now. And inside the parentheses, we have negative 4 plus 2, which is still negative 2. 2 times negative 2 is negative 4, which is what I got, which means that 4 is a solution because the equation is true. Are we okay? Cool. All right. Now, this next one, though, has fractions. Raise your hand if you love fractions. Oh, like how many people love fractions? Oh, man, I thought everybody was going to love fractions. How many of you hate fractions? Okay, should we just get rid of the fractions and pretend they never existed?
Yes.
Okay, well, I guess we can do that then. A fraction is just division. So this is x divided by 2 plus 3x divided by 4 minus 2 divided by 6 equals 10. Anyone see anything we could do right away, though? I wouldn't even try to get common denominators, but
Denominators are like multiples of 2.
They're all multiples of 2? Okay. Okay, yeah. Okay, so, sure. But really, if we wanted to, when you're dividing by something, how do you undo division? Multiplication. So if I'm dividing by 2, if I multiplied everything by 2, then that fraction's undone and I'm just left with x. Okay? If I went through and multiplied this one by 4, I'd be left with 3x because it's being divided by 4. But in an equation, if you do something to one part of it, you have to do it to the whole thing. Okay? If you do it to the left side, you have to do it to the right side. And in this case, if we do it to the left side, there are 3 terms, so you have to make sure you do it to all 3 terms. Okay? So, what number do you want to multiply by first? 2, 4, or 6? Doesn't really matter. You could multiply by any of them. So, okay, we'll do 6 first. And then I'll show you what we did in third hour. So, you multiply by 6. So, we're going to multiply every single term by 6. Okay, on the left and on the right, because in order for it to be fair, it's kind of like twins. You give one of them a sucker, the next one's going to cry, and we don't want that. So, you got to give both sides suckers. Okay? One day we'll get to triplets, and then it's a real mess. All right, so here we're going to have 6x over 2 plus 18x over 4 minus 12 over 6 equals 60. And what I just did was I actually made these so they're not even going to be fractions anymore. Because what is 6 divided by 2? So that's actually 3x. 18 over 4, that can reduce. What does that reduce to? 9 over 2, okay. So we have 9 over 2x. It does not matter. If that x is on the top of a fraction, it's the same thing as if it was next to the fraction. That does not matter. So if you like to think about it as a coefficient like that, that's totally fine too. Minus 12 over 6 is 2 equals 60. And I almost have it done. The only fraction I still have is that 9 over 2. So what could I multiply by to get rid of that fraction? So now I go through and I multiply everything by 2. And my first one becomes a 6x. Plus, if I multiply by 2 and divide by 2, I'm just going to cross those out because I know I'd have 18 over 2, which is 9. Or just cross them out. So 9x minus 4 equals 120. Do you have a question?
Yeah, I'm still kind of unsure. So when I multiplied them all by 6, I combined it.
Technically, you're multiplying by 6 over 1.
Yeah.
So you're only multiplying the numerators by 6.
Yeah.
Does that make sense?
Yeah, and okay, so it would result in it being 6x plus 9 or 6.
I think your question's up here. So when we multiply by 6, we have 6x over 2, which is what I wrote. But that's the same as 3x. And then in the next step is when we multiplied everything by 2, which is why we have 6x.
So what left the one with the denominator as 2 and y is the 26?
Well, because 6 is divisible by 2, but 6 is not divisible by 4. And that's why it doesn't end up having, that's why it still has a fraction. 6 is divisible by 6, and 6 is divisible by 2. And it was able to reduce to now have a denominator of 2, but that's why we had to multiply by 2. I'll show you in a minute what we did in third hour. There's many different ways you can do this to get rid of the fractions.
No,
And
I actually think I got it. Thank you. I made a mistake.
Oh, okay.
Thank you.
Okay, so to go on from this just looks very similar to kind of a combination of what we did in numbers 1 and 2, right? So from there, it shouldn't be too bad. I would combine like terms, so that's going to be 15x is equal to, I'm going to add 4 here too. 124. Okay. Divide by 15 on both sides. And then we get x is, and this is where everybody tends to go to their calculator. Then they go, okay, 124 divided by 15. And they want to write 8.2666667. But Mrs. Fox does not accept decimals. The end. So we don't deal with decimals in this class because then that would be rounded and it's no longer an exact answer. Okay, that's called an approximate answer, which eventually we'll deal with some approximate answers, but for right now, we want exact answers. Most of this year, we'll always find at least an exact answer and possibly, in addition to that, an approximate answer. So, what is the exact answer here when I divide by 15? That's it. 124 over 15 I could see if that fraction can be reduced. This one cannot. So I'm done. That's my final answer. Okay. Now, I'll show you what we did in third hour because they wanted to multiply by 2 first. So this might look a little sloppy. But they multiplied by 2, and that got rid of the first fraction, but the other 2 still had fractions. And then we said, okay, we'll multiply by 4 next. So we multiplied everything by 4, and that got rid of that middle fraction. And it still had that last fraction over there, so we said, okay, now we'll multiply everything by 6. So it is totally fine if you did it in 3 steps and multiplied by each of the denominators. You could multiply by 2, and then 4, and then 6. When we multiplied by 6, it actually got rid of 2 of the denominators, so we took a little bit of a shortcut compared to what third hour did. Okay? Either way, you'll notice we still, in the very end, got 124 over 15. That was our final answer. But the difference was we were dealing with much larger numbers here once we got to something that looked more familiar. And our first fraction that we got for an answer was 496 over 60. And that wasn't acceptable because it wasn't yet simplified. But I saw that both were even numbers, so I just divided both by 2. And then again, those are both even numbers, and divided by 2 again. And that's where I ended up with the 124 over 15, which is exactly what we got. We just did it in a couple less steps. So I wanted to show this to you because if you are doing it one way, and maybe your friend went about it a different way and you're discussing it, it doesn't necessarily mean that you're wrong, but you might be going a different route than your friend. But you can still get to the same answer. Okie doke? All right. So, flipping it over, we also have to know how to solve equations when there are only variables. Okay. I guess there are some numbers in there too. But what it wants us to do is it wants us to get B1 by itself. Now, this is something that you probably will use in your science classes, okay, where you have to rearrange an equation to be solved for something else. Okay. Now, that B1 is part of those parentheses. So what we want to aim to do is get the parentheses by themselves so you no longer have to have the parentheses, and then get rid of the other stuff in there so that B1 will be all by itself. So, those set of parentheses right now are being multiplied by 1/2 and being multiplied by h. Okay? How can you undo being multiplied by 1/2? You could divide, but I don't like dividing by fractions. So what could you instead multiply by? Okay, what did I tell you? What is happening in a fraction? Division. So right now this says it's multiplying by 1 and dividing by 2. So what would you, if it's dividing by 2, how do you undo division? Multiply by 2. Okay? Which is actually multiplying by the reciprocal. If you're multiplying by a fraction and you multiply by the reciprocal, that's your opposite. Okay? So, if I multiply both sides by 2, on the left side, I'm going to have 2a. 2 times a is just 2a. And on the right side, I have 2 times, and I'm going to write this out. On your homework, you wouldn't have to write out this step, but I want you to see it. Okay. On the right side, this is all one term because you have that 1/2 multiplied with the parentheses multiplied with the h. You don't have multiple terms there. Okay? So when you multiply the right side by 2, this whole thing is being multiplied by 2, and that 2 times 1/2 goes away. Right? 2 times 1/2 is actually just 1. That's why you don't have to write it. All right. Now, what else is happening with those parentheses, though? Those parentheses are also being multiplied by h. So how do you undo multiplication? Division. The reason why we said not division the first time, because we didn't want to have to divide by a fraction. But we can divide by h. That's no big deal. So our h's then will cancel on the right. On the left, I'm just going to write it exactly how it looks. 2a over h is equal to b1 plus b2. Now that those parentheses are alone, you no longer need the parentheses there. All right, we're still aiming to get b1 by itself, but right now we're adding b2 to it, so how do you undo that? Subtract b2. Now that we're subtracting, we're adding a second term on that left side. So our answer is going to be 2a over h minus b2 is equal to b1. Now we have this rule in math, and it's that you're not allowed to divide by 0, okay? But division is a fraction, right? So if you put a 0 in a denominator, that means you're dividing by 0. You can even do it on your calculator. Watch what happens. If I do 5 divided by 0, it will tell me that that's an error, that it does not exist. You cannot do it. It's undefined. I can do 0 divided by 5, so if you ever can't remember what is the rule, you could always try it on your calculator. The one that gives you the error, that's where 0 is not allowed, is in the denominator. So then when we look at your example here, or your equation here, what's in the denominator right now?
1. You don't know.
We don't know because it's a variable. It's h. So we have what we call a restriction. And our restriction is that we have to say that h is not allowed to be 0. It cannot be 0, because if it was 0, then that equation would be undefined and you couldn't do anything with it. Yes, Corey?
I thought b1 and b2 had a denominator of 1.
Is 1 ever going to get to 0?
What?
1 will never be 0.
I know.
So you don't have to worry about that.
Yeah, okay. I was just saying that's the denominator.
Yeah, they do have a denominator of 1, but you can divide by 1. There's no rule saying you can't do that. So the restriction is that this variable is not allowed to be 0, because then we would be dividing by 0. So that's the restriction that goes along with that equation.
So it only applies to the variable.
It only applies to a variable if it's in the denominator, because we cannot divide by 0. All right, this last one. You may not remember the term factoring, because it was from way back in Algebra 1. But for some reason, you guys are really good with distributing. So I'm going to say that factoring is kind of like undistributing. So something was distributed to both of these terms that was the same. Now we're supposed to be solving for x. And see how x is in both of those terms? It's almost like it was distributed to both of those terms. So I'm going to undistribute it. Okay, I factored it out. It was a common factor in both of those terms, so I pulled it up front. All right. Now, x is being multiplied by that jumbled of a mess of parentheses. So in order to get x by itself now, I can just divide by that jumble of a mess of parentheses. And the parentheses over here will then cancel. And on the right side, so on the left I just have x, and on the right I'm going to have w over y plus 2z. And that one's done as well. Now this one also has restrictions because you can see there are variables in a denominator. So our restriction here is that this denominator is not allowed to be 0. But it's not just a variable now. It's an expression. So we have to write it as y plus 2z is not allowed to be 0. Okay, I have like 2 more quick things to show you. And one is just an example of when you wouldn't need a restriction. If your final answer was a is x over 2, our restriction on that would be 2 cannot equal 0. You guys can't even see what I'm writing. So if we had a is equal to x over 2, our restriction would be 2 cannot be 0. But that's not necessary Because 2 will never be 0. So there's actually no restriction on this one. Okay, yes, Corey?
For number 5, and I just have a theoretical, could you also maybe, after you get the x separated, could you also divide by x and end up with y plus 2z?
You're trying to get x by itself.
Yeah.
If you were to divide by x, x would be in the denominator, and you'd be going backwards. You don't want x in the denominator. You want x to be in the numerator, since that's what you're solving for. Okay. The other thing that I was going to show you is something that might look more familiar. If I said, what's 3x plus 7x? What do you know that it is? Okay, and the reason for that is because you're actually thinking of x as being outside of a bracket of 3 plus 7 because it's a like term of both. That's how you're getting 10x. This is the same idea that we did up here. Those are like terms of a form of an x, and that's why you can take the x out. Does that make sense? That's all I have for notes for you guys today.